Hello, all you lovely people. Welcome to What's Up, your monthly guide to the sky. We are currently in the month of February, and there is a big event that is going to be taking place. The Perseverance rover will be landing on Mars. And in a few weeks, I will have another podcast for our Mars-themed week here at MSUM Planetarium that will talk more about Mars. But for now, I would like to talk about 4 different events that will be happening during this month. Now, the first event that I would like to tell you all about is the Alpha Centauri meteor shower. The Alpha Centauri meteor shower has been observed yearly since its discovery in 1969. The meteors from the shower can reach speeds of 59 kilometers per second. The Alpha Centauri meteor shower will be active from January 28th to February 21st, producing its peak rate of meteors around February 8th. During its peak, around 7 meteors an hour are visible. Over this period, there will be a chance of seeing Alpha Centauri meteors from anywhere where the shower's radiant point, which is in the constellation Centaurus, is above the horizon. Unfortunately, it will not be visible from Moorhead at any time, since its radiant point never rises above the horizon. Unfortunately, that is where I am, so hopefully the rest of you will be able to view the shower and possibly let me know how it goes. Meteor showers arise when the Earth passes through streams of debris left behind in the wake of comets and asteroids. Over time, the pieces of grit-like debris in these streams distribute themselves along the length of the parent object's orbit around the solar system. Shooting stars are seen whenever one of these pieces of debris collides with the Earth's atmosphere. Such showers reoccur on an annual basis. The meteors that are associated with any particular meteor shower can be distinguished from others because their paths appear to radiate outwards from a common point on the sky, which points back in the direction from which their orbital motion brought them. The Alpha Centauri is named after the constellation from which its meteor shower appears to radiate, Centaurus. Centaurus is one of the largest constellations in the night sky and contains 2 of the 10 brightest stars, including Alpha Centauri, the closest star to our Sun. The dead center of the radiant of this meteor shower is 4 degrees north to the bright star Hadar, which is also known as Beta Centauri. The second event that I would like to talk to you guys about is the one and only Perseverance rover landing. So the Perseverance rover was launched on July 30th, 2020, and on Thursday, February 18th, 2021, Perseverance will touch down on Mars at approximately 12:30 p.m. Pacific Standard Time. During the landing, the rover plunges through the thin Martian atmosphere, with the heat shield first, at a speed of over 12,000 miles per hour. A parachute and powered descent slow the rover down to about 2 miles per hour. A large sky crane then lowers the rover on 3 brittle cords to land softly on 6 wheels. Landing on Mars is very challenging. Only about 40% of the missions ever sent to Mars by any space agency have been successful. Perseverance is only the 5th NASA rover to attempt landing on Mars. So let's cross our fingers for our little buddy Perseverance in hopes that he has a very safe and successful landing. The rover's new home is Jezero Crater, a large impact crater about 28 miles wide just north of the Martian equator. Jezero once contained a lake which scientists think is one of the most ideal places to find evidence of ancient microbial life. If life exists anywhere else in our solar system, chances are it might be at Jezero Crater. The main question Perseverance is trying to answer is, was there ever ancient life on Mars? To answer that question, the rover will collect and store the most compelling rock and soil samples for return to Earth by a future mission. Once on Earth, scientists can use a variety of sophisticated instruments, many of them too large and bulky to transport to Mars, to help answer this question. And lucky for us, we are actually able to explore Mars with Perseverance. As the rover begins its mission at Yazeto Crater, you are able to visit the mission website for the latest news and images every day. The next event that I will be talking about is going to be happening on February 22nd, when the asteroid 29 Amphitrite will be at opposition. Asteroid 29 Amphitrite will be well-placed lying in the constellation Leo, well above the horizon for much of the night. Regardless of your location on Earth, 29 Amphitrite will reach its highest point in the sky around midnight local time. This optimal position occurs when the asteroid makes its closest approach to the point in the sky directly opposite to the Sun, an event termed opposition. Since the Sun reaches its greatest distance below the horizon at midnight, the point opposite to it is highest in the sky at the same time. At around the same time that 29 Amphitrite passes opposition, it also makes its closest approach to the Earth, termed its perigee, making it appear at its brightest in the night sky. However, even at its brightest, 29 Amphitrite is a faint object beyond the reach of the naked eye, so binoculars or a telescope of moderate aperture will be needed to view this event. The last event that I would like to talk to you guys about is when Mercury reaches its highest point in the morning sky. So Mercury's orbit lies closer to the Sun than the Earth's orbit, meaning it always appears closer to the Sun and is lost in the Sun's glare much of the time. It is observable for only a few weeks each time it reaches the greatest separation from the Sun, moments referred to as greatest elongation. These aberrations repeat roughly once every 3 to 4 months, taking place alternately in the morning sky and evening skies, depending on whether Mercury lies to the east of the Sun or to the west. When it lies to the east, it rises and sets a short time after the Sun and is visible in early evening twilight. When it lies to the west of the Sun, it rises and sets a short time before the Sun and is visible shortly before sunrise. However, some times of the year are more favorable for viewing Mercury than others. From Moorhead, it reaches a maximum altitude of between 8 degrees and 18 degrees above the horizon at sunrise during each morning apparition, depending on the time of the year. During its February-March 2021 apparition, it will peak at 9 degrees above the horizon at sunrise on February 25, 2021. This variability over the course of the year is due to a combination of two factors. The first factor is that at all times, Mercury lies close to a line across the sky called the ecliptic. This line traces the path that the Sun takes through the zodiacal constellations every year and shows the plane of the Earth's orbit around the Sun. Since all of the planets circle the Sun in almost exactly the same plane, it also closely follows the planes of the orbits of the other planets too. When Mercury is widely separated from the Sun, it is separated from it along the line of the ecliptic. But at different times of the year, the ecliptic meets the horizon at different angles at sunrise. This would translate into Mercury being at different altitudes above the horizon, even if its separation from the Sun was constant. If the ecliptic meets the horizon at a shallow angle, then Mercury has to be very widely separated from the Sun to appear much above the horizon. Conversely, if the ecliptic is almost perpendicular to the horizon, Mercury may appear much higher in the sky, even if it is actually much closer to the Sun. The seasonal dependence of this is that at sunset, the ecliptic makes its steepest angle to the horizon at the spring equinox, in March in the northern hemisphere, and in September in the southern hemisphere. Conversely, it meets the horizon at its shallowest angle at the autumn equinox. Because the seasons are the opposite in the northern and southern hemispheres, a good apparition of Mercury in one hemisphere will usually be badly placed in the other. At sunrise, these dates are also inverted, so that for morning apparitions of Mercury, the ecliptic makes its steepest angle to the horizon at the autumn equinox, and its shallowest angle to the horizon at the spring equinox. A second factor is that Mercury is unusual among the planets for having a significantly non-circular orbit, which varies in its distance from the Sun by 52% between its closest approach and greatest distance. This means that Mercury's separation from the Sun at greatest elongation varies. So, if Mercury appears in the evening sky in mid-September or in the morning sky in mid-March, then it appears more widely separated from the Sun than usual. Specifically, at each apparition, Mercury reaches a separation from the Sun of between 18 and 28 degrees. During its February-March 2021 apparition, it will reach a maximum separation of 27 degrees to the Sun's west at greatest elongation. Thank you guys so much for listening. I hope you learned a lot. If you have any questions or events that you would like to know more about, please leave them in the comments and I will try to get to them as soon as possible. Also, make sure to follow MSUM Planetarium on our social medias for other events and other fun things that we do here at the planetarium. And until next time, I hope you enjoyed getting to know what's up.